Problem number 4 on spring 2015 gives us an integral, gives us dx over x squared plus 6x plus 5 quantity squared, and it says use trig sub to transform the integral into a trig integral. But it doesn't say solve it, so if you look at all the answers, they're all left in terms of theta unsolved. So all we have to do is figure out the substitution, plug it in, and from there we can just leave it and we can say that we answered the question. So I see x squared plus 6x plus 5. When I see that, that doesn't really fit the bill of any kind of substitution that I know. Again, I'm looking for like an x squared plus a squared minus x squared, or x squared minus a squared, to try to get either a sine, tangent, or a secant in there. But what I do know is that when I have something like that, what I can do is I can complete the square and try to convert it into a form that I can do a substitution on. So what I'm going to do is I'm looking at this, I'm going to write this off to the side, x squared plus 6x plus 5. And I'm going to go ahead and complete the square on this. So to complete the square, I look at the middle term, the b term. I divide it by 2. So 6 divided by 2 is 3. And then I square it. So that becomes 9. So what I'm going to do is I'm going to add and subtract 9 from this equation to complete the square. So I have x squared plus 6x plus 9 minus 9 plus 5. Now one of these terms that I added to it is going to complete that square and turn it into a perfect square that I can then factor. In this case, the plus 9 is the one we're looking for. If I go ahead and write this term as a perfect square, I end up getting x plus 3 quantity squared. And you can go ahead and check my work by factoring that back out. You should get x squared plus 6x plus 9. And after that, I'm left with a minus 9 plus 5, so that means I end up with a minus 4. Okay, so now what I see from here is that I have this x function squared minus a constant. Because of that, that tells me that that's going to be a secant substitution. Because remember, if it's x squared minus a squared, that has to be a secant theta. So what I'm going to do is I'm going to go ahead and write out my substitution first before I do anything else. So I have x plus 3 is equal to, remember this is a squared, so the a term I'm actually looking for is 2, and then it's going to be secant of theta. So this is the substitution that I'm going to plug in. Now, the other thing I need to find, and don't forget about this term up here, I need to find my dx. So to do that, I'm going to derive both sides. X plus 3 derived is just dx. And that's equal to, when I derive this term, I end up with 2 secant theta tan theta. And I also have a d theta out there. We don't want to forget that term. So now I have my substitution ready to go. So what I can do is I can go ahead, and first off, I'm just going to rewrite this integral in terms of the completed square. And that's just for the sake of completion, because it's good notation to always write down your steps in case you do get stuck somewhere and you have to work your way backwards. X plus 3 quantity squared minus 4. I know what I'm subbing in for all of that. So I'm going to go ahead and plug in this x plus 3 term. Oh, also, that's why you always write it out too. This whole thing is quantity squared. Almost left that out. So this x plus 3 term, if I go ahead and plug that in, actually I guess I'll write out the dx first. So that's 2 secant theta tangent theta d theta. And then on the bottom, I have x plus 3 quantity squared. So that's going to be 4 secant squared theta minus 4. And then I'm going to have a quantity squared around that. Okay, good. So now, again, what I'm looking for with trig substitution is I'm looking to simplify something using a trig identity. When I'm dealing with something like this, I have a secant squared minus a number, so what I can do is I can pull a 4 out of both of those terms, and I think I'll actually do that to make it maybe a little clearer. So I still have a 2 secant theta tan theta d theta on top. That hasn't changed. What I can do is I can pull a 4 out of both of those terms. I'm left with a secant squared theta minus 1. Now, thinking back to my trig identities, I know that 1 plus tangent squared theta is equal to secant squared theta. So therefore, if I subtract the 1 off, secant squared theta minus 1 is just equal to tan squared theta. So what I can do is I can go ahead and I can write out, this is just going to be tan squared theta. And this is still quantity squared, all on the outside. I don't want to forget about that term. It's going to be a little bit off if we forget that. So now what I can do is I can go ahead, and now we need to do some simplification. So the first thing I'm going to do is I'm going to square this whole term on the bottom and write out what we get. So I'll continue that up here. I have 2 secant theta tan theta d theta. And then on the bottom, I have 16, 4 squared is 16, tangent to the 4th theta. Okay, great. So now, the first thing I notice is I can cancel out one of those tangent terms. So this is going to go to 3 on the bottom. And I can also simplify this constant term, and I can pull it out front. 2 over 16 is 1 over 8. I can just go ahead and write that as 1 over 8 on the outside. Okay. Now, the one thing I notice is that when I look at all the answers for number 4, they all have 1/8 in front. So sometimes the constants might give away the answer. But in this case, it looks like we're not going to get any help from there. So we need to keep going and try to simplify a little bit more. So I have a secant theta over tangent to the 3rd theta. I need to figure out some way to reduce that down. But I don't really see anything I can do. And it doesn't look like anything in here is really kind of giving me a hint. Although what I do notice is that a lot of them do have sines and cosines in them. So what I can do is I can actually reduce these down to their sines and cosine form. And maybe I can try to simplify a little bit more. So what I'm going to do is I'm going to go ahead and write that out. I have a 1/8. I write my integral sign. Secant is 1 over cosine of theta. And I have tangent cubed theta, which is sine cubed over cosine cubed. But because I'm dividing by it, I'm going to multiply by its reciprocal. So what I actually end up getting is I end up getting cosine cubed theta over sine cubed theta. Good, good. Now I have a d theta out here. Okay. So I notice that I can cancel out one of these terms now. That's left with a squared. And now I'm kind of stuck again. So I have a cosine squared and I have a sine cubed term. And I need to figure out what to do. Well, in this case, what I'm going to do is I'm just going to have to kind of make a guess here, try something and see if it works. But one thing I notice is that cosine squared, I can also use a trig identity to change that form. So in this case, what I'm going to try to do is I'm going to try to convert it into sine terms. So that way, maybe I can make some kind of use out of this term down here and see if I can get some terms to cancel. Remember, if I have 2 terms on top separated by a minus sign and 1 term on bottom, I can always write them as 2 independent integrals. And I do see a couple of the answers in there do have terms that are separated by pluses and minuses. So they must be using some kind of trig identity to reduce that down. So what I'm going to do is I'm going to use the identity sine squared theta plus cosine squared theta is equal to 1. And if I go ahead and look at that in terms of just cosine squared theta equal to something, I end up getting 1 minus sine squared theta is equal to cosine squared theta. So I can now rewrite this integral one more time. And I end up with 1 minus sine squared theta over sine cubed theta d theta. Okay, good. So now I have this term. And what I can do now is, because I have 2 terms up here and 1 term down here, I can split them and write them as independent integrals, separated by a minus sign. So I have 1/8 integral. I have 1 over sine cubed theta minus sine squared theta over sine cubed theta. Okay? And I do notice about this term, I can go ahead and cancel out those top 2, cancel it out with the cube down there, and I'm left with 1 over sine theta in that second term. So now what I need to do is I need to look at my answers and see if it matches anything. So I see some of them with secants. I don't really have secants. I just have sines and cosines. Well, the one that stands out to me is letter E. Letter E has these written as cosecant cubed minus cosecant. Well, 1 over sine is cosecant, so I can actually just go ahead and rewrite the form and turn it into cosecant cubed theta minus, this is 1 over sine, so that's cosecant theta, d theta. And looking at my answer, that matches the form perfectly. So we've arrived at our final answer, which is letter E.
The Teaching Center, UF's Learning Resource Center.